For the most powerful computers we have, the absolute limit, it used to be just 13 seconds.
13 seconds, yeah.
That's how long they could stay running before, well, physics basically shut them down.
It sounds like a long time in maybe pure computation terms, but in reality, nothing. Imagine trying to run anything serious knowing the whole thing's going to collapse.
Exactly. That limit, atom loss, it was the ceiling for quantum. But the sources we looked at today, they show this huge Harvard breakthrough.
Right.
A physics team built a system, a quantum system, that actually repairs itself mid-calculation.
Whoa. Okay, that changes everything, seriously. We're shifting from these, super delicate lab demos
Can you miss it? Yeah.
to a real possibility of, always-on quantum servers. That's the pivot. For the real world, for commercial use. Huge.
Welcome to the deep dive. We're going to pull on 3 big threads from the sources you shared with us. And the theme that kind of ties them together is this hunt for reliability, whether that's securing AI for businesses or keeping these quantum machines actually running.
Yeah, and our roadmap really shows how deep that goes. First up, we're going to unpack IBM's big move, very strategic one, I think, into open source AI with Granite 4.0.
Okay.
Then second, we'll look at this boom in AI agents and agentic systems and what they're actually becoming, the practical tools for businesses.
And finally, we dig into that quantum breakthrough, the self-healing machine, the one that gets rid of atom loss, making these really long computations possible, truly possible for the first time.
Right.
Okay, let's start with Granite.
Do it.
So IBM rolled out this Granite 4.0 family, and their positioning seems really clear.
Yeah.
It's hybrid, it's enterprise ready, and crucially, open source.
Exactly.
They don't seem to be chasing the, biggest model trophy. It feels more like the most deployable one.
That distinction, it's everything here. This isn't just another, hey, look, a big model announcement.
Yeah.
It's a strategic play designed for, the messy reality of corporate IT. They even made it light enough to run on pretty cheap GPUs.
Yeah.
Which, for companies wanting to use it internally, maybe on the edge, that's critical.
And the performance numbers are honestly kind of surprising for the size. The 3 billion parameter Granite model, it actually beats their own older 8 billion parameter model in some key areas.
Yeah, beats its big brother.
Right.
That's pure efficiency. And it matters because, okay, get this, 70% less memory needed to run it.
70%. Wow.
So businesses can run this on hardware they maybe already have, or cheaper stuff, right now. And here's something really interesting for anyone dealing with lots of data.
Okay.
The core design has linear scaling, meaning if you feed it more input, like a huge document, massive context, it actually gets faster, not slower.
Wait, faster with more input? That's counterintuitive.
I know, but it's a huge win for companies just drowning in documents and data they need to process. Big deal.
And beyond just the efficiency, the sources really hammered the security and compliance side. It's licensed under Apache 2.0, which means it's properly open, none of those weird restrictive clauses we've seen pop up elsewhere.
Right, but maybe the real kicker for big regulated companies. This is the first major open model that has governance baked right in from the start. It's ISO 42001 certified.
ISO 42001.
Yeah, think of it like a giant pre-approved security blanket for companies where compliance is everything.
Okay, hold on, though. That ISO certification, that sounds like a lot of hoops to jump through, a lot of overhead. Is that really the most critical feature here, or is it maybe more marketing?
No, I think it's genuinely critical. I mean, yes, the efficiency for edge stuff is also vital, absolutely. But for a lot of enterprises, their legal team will just shut down any open model project if those governance guardrails aren't there, period.
Ah, okay.
So IBM's basically saying, look, we did the really hard compliance paperwork so your lawyers don't kill your AI plans. They're jumping into that gap, that uncertainty left by, say, Meta's licensing.
So the goal isn't really to be the most powerful model, but the most trustworthy, the vetted, secure, efficient option compared to maybe Llama or Quinn. So companies can build agents but still keep control.
Exactly. Keep control of the whole stack.
That makes a lot of sense. Okay, let's shift gears then. Let's talk about those agents.
Right, agents, we keep saying the word. So a simple definition. An agentic system is AI that's designed to do things, to perform actions, not just, answer a question you type in. They're proactive.
And this whole trend is moving so fast. I mean, just to show how serious this is, one of the sources mentioned a senior Google engineer just dropped this huge 424-page document,
Wow.
free to download, called Agentic Design Patterns. It lays out how to actually build these things properly. That tells you a lot about where the focus is shifting. Structure.
And the competition is fierce. OpenAI, they're releasing something called an Agent Builder, which looks like a direct challenge to tools people already use, like Zapier or N8N for workflow automation.
Interesting.
Yeah, I mean, people have been building these sorts of wrappers around LLMs for a bit now, but when the big platform providers start building integrated tools themselves, that's a major shakeup for those existing companies, a real threat.
It does feel like a big leap, though, going from just, typing a prompt into a box to setting up these complex multi-step agent things. I bet a lot of people, even if they use AI daily, find that sequence part tricky.
That's fair. And it points to the challenge right now. I'll admit, it's still complicated even for me sometimes. I still wrestle with prompt drift myself sometimes, making those really complex multi-step prompts work reliably.
Yeah.
It's not always smooth sailing yet.
All right.
Which is why we got to focus on the practical wins first.
Exactly. And we found some good stuff in the sources on that, like how to use single prompts, just one command, in tools like Google's Notebook LM to get really specific structured stuff out quickly. Cuts through that complexity.
Yeah, that's where the immediate value is, I think. Like, imagine getting a full meeting summary from a 90-minute recording with one prompt. Or creating a study guide that pulls info from 3 different documents. Or drafting a whole 30-day content plan. Boom, done. These are real, actionable things you can do with one command that save, actual hours.
And we're seeing these tools pop up right in the daily workflow now. Google's apparently put its AI coding agent, Jules, they call it, right into terminals and Slack.
Yeah.
So it's moving out of the lab into the places you actually work.
And the money's following the practical use cases, too. Like, Inspiron raised $100 million for an AI platform that helps improve care and efficiency in senior living facilities.
Wow, $100 million.
Yeah, agents are going straight to where the real operational headaches are, solving actual problems like staffing, task management, concrete stuff.
So it's really that shift from the model answering us to the model doing stuff for us. That difference feels like the core of this next wave in business automation.
How fast do you think we'll see this agent tech move?
Yeah.
From just being wrappers to actually handling complex tasks without a human watching every step?
That's the big question. But given the speed things are moving, I think automating specific complex business tasks feels, imminent. It's coming fast. Okay, let's pull back a bit now. Look at some of the big industry headlines that kind of give us the vibe of the whole market, the push and pull happening.
Well, the biggest drama, obviously, is still the OpenAI and Musk thing.
Yeah.
OpenAI really fired back at his lawsuit over trade secrets.
Oh, yeah. What'd they say?
Called it basically harassment, a tactic just meant to slow them down. So, yeah, that feud is definitely still simmering. Hotly.
Meanwhile, despite all that noise, the money just keeps pouring in. OpenAI apparently just officially became the world's most valuable private company.
Yeah, which just underscores the insane level of investment happening right now.
It is this really intense mix, isn't it? Like massive valuations on one side, and on the other, you've got Sam Altman himself warning the whole AI industry might be heading for a, quote, spectacular implosion.
That's a pretty stark warning, especially coming from the guy leading the most valuable company in the space.
Yeah, high stakes. What it tells me, looking at these top stories, is that everything's moving at once. The deep infrastructure stuff and the user experience stuff. Like, look at NVIDIA. They launched this AI aerial tool, uses their GPUs to actively boost 5G and even 6G networks.
Yeah, they're basically plugging AI straight into the core global communication grid, making sure they stay dominant at that hardware level.
And then on the user side, you see Apple making big moves, apparently looking outside the company for a new AI chief.
Which signals they know they need fresh talent, maybe need to play catch-up fast in some areas.
These are huge structural shifts. And then there's just some interesting little details, too, for flavor. Google pushed Nano Banana into full production.
Nano Banana?
Yeah. Apparently, it now supports 10 new aspect ratios.
Yeah.
And this is big for creators. You can get just the image out. No need for text prompts mixed in, image-only output.
Okay. That's useful. And you can't ignore the cultural side either. The sources mentioned that viral trend, recreating famous movie scenes.
Oh, with Pikachu.
Yeah. like Batman or The Godfather, but starring Pikachu.
Yeah.
It just shows how quickly this high-quality generative AI stuff is hitting, like, mainstream culture. It's accelerating.
And speaking of accelerating, Meta's moving on hardware too. Users are apparently testing live navigation features right now on their AI Ray-Bans.
Whoa.
Yeah, imagine getting directions prompts right there in your glasses as you walk around.
So you've got this crazy tension, right? Unbelievable valuations,
Yeah.
serious warnings about a bubble, but underneath it all, the actual infrastructure is being rebuilt super fast.
Yeah.
It's wild.
Yeah. Does that title, Most Valuable Private Company, even mean that much when the founder is warning about a market implosion?
Well, it really highlights the conflict, doesn't it? Massive investment hype running headlong into these deep worries about whether the industry's growth is sustainable or just moving too fast.
Mid-roll sponsor read placeholder.
Okay, this next piece, this quantum breakthrough, it feels genuinely, like, profound. We mentioned earlier how fragile quantum computers are.
Right, the 13-second limit.
Yeah, for years, atom loss just meant even the best machines tapped out, around 13 seconds, which is why you couldn't do long, complex, continuous calculations. It was scientifically just impossible.
Physics itself imposed that limit. But this Harvard team, it seems like they beat it by focusing on continuous operation, their solution, actively replacing the atoms that get lost, in real time, mid-calculation, without messing up the quantum state.
The way they do it is pretty brilliant. They use something called an optical lattice, basically. Super-controlled light beams holding atoms and combine it with optical tweezers.
Tweezers made of light.
Yeah. They grab fresh atoms and just slot them into the empty spots left by the lost ones. And they can do it incredibly fast, injecting something like 300,000 atoms per second back into the system.
Wow. So it's like a self-healing machine, but at the atomic level?
Exactly. It holds 3,000 qubits, which is already impressive, and keeps that delicate quantum state going even while this atom refresh is happening constantly in the background.
And that one change, it just unlocks everything that was blocked before, doesn't it?
Totally. Suddenly, long, complex calculations, they're actually possible. It gives us a clear path toward real quantum programs that run like, actual robust apps, not just these fragile 13-second demos.
Yeah.
Whoa. I mean, just imagine scaling that. 1 billion queries, maybe?
Yeah.
When you don't have to constantly restart the machine every 13 seconds, that continuous power, it just rewrites the whole commercial roadmap for quantum.
Which is why people are calling it a potential iPhone moment for quantum computing. AWS is Harvard's partner on this, and you can bet Microsoft, Google, they're all watching this incredibly closely.
Oh, yeah.
Because if you solve the stability problem, you basically solve the commercialization problem.
Yeah, given how fragile things have been, is this mid-calculation repair system, is that the real key? The thing that finally unlocks commercial quantum computing?
It feels like it has to be, right? Continuous operation seems like the absolute prerequisite for having always-on quantum servers that businesses can actually rely on and use widely. It moves it from physics lab curiosity to potential enterprise tool. Hashtag tag tag outro.
Okay, so let's boil this down. 3 key nuggets we pulled out for you today.
Go for it.
First, enterprise-ready, secure, open-source AI is definitely here. IBM's Granite 4.0 is leading that charge with its focus on efficiency and, crucially, those compliance guardrails.
Right. Second takeaway, AI agents are moving fast. They're automating professional work, going beyond simple chat into real tools like OpenAI's Agent Builder and those super useful single prompt commands for specific tasks.
And third, quantum computing just took this absolutely massive leap. They solved the core instability problem. That creates a real, viable path towards continuous, always-on quantum power, finally.
It's such an interesting contrast when you put it all together from the sources, isn't it? On one hand, this huge necessary push for control, like the ISO certification for Granite, making it safe to deploy.
Yeah.
And on the other hand, this giant leap into almost uncontrolled power with these always-on, self-healing quantum machines. But both roads are really aiming for the same thing, ultimate reliability.
Yeah, it's that moment where fragility finally starts giving way to actual functionality. You can see it happening.
It leaves us with maybe one last thought for you to chew on. If quantum machines can now repair themselves in real time, constantly, to keep running, what processes, what systems, maybe in your own work life, are due for that kind of constant self-healing upgrade?
That's good food for thought. Well, thanks for joining us for this deep dive into your sources.
Yeah, thanks everyone. We'll catch you next time.